Our next chapter is about hypothesis tests. So we're going to start out with some basic ideas and explanations of what a hypothesis test is. We also call it a significance test. So a hypothesis test is a test to determine if an assumption about a population parameter is true. And we'll be doing some examples a little bit later on. If you don't understand the idea behind it in the beginning, don't worry about it. Once we start section 9.2, that goes into more detail about how to actually perform these tests. So our first thing is our null hypothesis. And we always write our null hypothesis, we always start it off with an H0. So that's how you see it written. So the word null tends to mean usually something along the lines of no difference or no change. So what we're going to do is, this is just, I'll give you the definition. The basic idea, though, is it's the claim that we weigh evidence against. And one thing that's important with our null hypothesis is it's always going to, and at least in this class, it's always going to be written with an equal sign. Occasionally you'll write it in words, but generally the idea of it is going to be with an equal sign. The alternative hypothesis, which we will we'll write it as HA. Sometimes you'll see the A capitalized, sometimes you'll see it lowercase, it doesn't really matter. So the alternative is, I'm going to say it's generally the claim that we suspect to be true or that we hope to be true. But the big thing is that it's that there has been a change of some sort. So we'll do some examples and you'll see where this is. And this one we're going to use, it's always going to use either a less than, a greater than, or a not equal to. At least when we write out in symbols. Like I said, we might be writing these in words occasionally also. So for our first example, we're going to be writing our first hypotheses. So they're telling us that last year the mean weight of some pineapples was 31 ounces. So you'll notice right away that we're looking at means. A new irrigation was installed. They wonder if the change increases the mean weight of pineapples in the field this year. So they're going to ask us to state appropriate hypotheses, and also we want to define the parameter of interest. I'm actually going to go backwards, and I'm going to do the parameter of interest first. In general, with all hypothesis tests, you're going to want to state your parameter first. It's kind of like when you do word problems and you start by defining a variable. So remember that we're working with means and we're working with the parameter. So we're going to be looking at the population mean, which is the Greek letter mu. In this case, mu is going to be the mean weight of the pineapples this year. And what we're trying to prove, we're going to do, first of all, our null hypothesis, remember, is H0. Our alternative is HA. The managers are wondering if the mean weight has increased. So that's going to be our alternative hypothesis. So the way that we're going to write this is, we're going to write it as mu is greater, and by the way, this should be 30, it's greater than 30. This would mean, if this was true, this would mean that the mean weight increased. By the way, the stuff I'm writing in blue, you don't have to write it every time. You can if you want to. You need to somehow define what your variable is. So if you didn't define the parameter on the side, you can always get around that by doing what I did here and explaining what the hypothesis in words. And actually, your alternative and your null are always going to be the same format with the exception of this being equal. So what the null hypothesis is, it's saying that the mean weight is still 30. In other words, we're saying with the null that the mean weight hasn't changed. So that's why I said above that the null hypothesis is generally going to be that there's no difference, and I actually didn't write no change, but it can be no difference or no change.